Good evening and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is lesson 4 on probability of the binomial distribution and we're going to be going through example 3 which you would have seen at the start of this video as a screenshot. What we have here is a car salesman who has a probability of making a sale of 0.05. And they are expected to make at least one sale a day. And the question we're asking is, how many customers would they have to see? So the probability of them making at least one sale was at least 0.99, or exceeds 0.99. So I've said let x equal the number of sales. Then x would follow the binomial distribution n, because we don't know how many customers there are, that's what we're finding out. But we know the probability of selling a car to each of those customers is 0.05. And the question we're being asked to consider is the probability that x is less than or equal to 1 has to be greater than or equal to 0.99. So the first thing that we're going to consider then is, if we want the probability of greater than or equal to 1, then we want to know from 1 to n, which means that the only result that we don't want is 0. So rather than working out the probability that x is greater, or to work out the probability that x is greater than or equal to 1, what I'm actually going to do is work out 1 minus the probability that x equals 0, and that has to be greater than or equal to 0.99. I'm going to do a little bit of manipulation of this here, so I'll do it the same way as I did in the previous example. The probability, or subtracting the 1, and then multiplying through by -1. So the probability that x equals 0 has to be less than or equal to 0.01. Now, to work out the probability that x equals 0, we need to go back to when we very first talked about the binomial distribution here. X equals 0 means I'm getting no successes. And what that means is that I'm failing every single time. So if the probability of success is 0.05, then the probability of failure must be 0.95. And if I'm failing every single time, then I'm failing n times, because I'm failing to sell a car to every single customer that I see. But that has to be less than or equal to 0.01. So what we have now is, we have a number to a power is less than or equal to a number. We're going to solve this equation using logarithms. So what I'm going to do is put a bracket in there. I'm going to take logs of both sides of this equation. So log of 0.95 to the power of n is less than or equal to log of 0.01. I'm going to come up here for the next bit, say n log 0.95 to be less than or equal to log of 0.01. So that's using the powers rule. Power n can be brought to the front of the logarithm. I now have n multiplied by log 0.95, which is a number. I can divide by that number. However, log of 0.95 is a negative number. Log of 1 is 0. Therefore, log of a number between 0 and 1 is negative. And what that means is that the inequality symbol will change direction. Let's just consider this in the context of the question. We're being asked what is the minimum number of customers that he needs to see to make sure his chance of selling a car exceeds 99%. So what's the minimum he has to see? You would expect that to be more than a certain value, not less than a certain value. So just thinking as you work through, am I happy with the direction of my inequality? Yes, I am in this case. Now, the answer to that, if I go into here, so I'm going to do log of 0.01 over log of 0.95. That is 89.78. So n has to be greater than or equal to 89.78. N has to be an integer because it represents the number of customers that you're going to see. So n is the next number greater than 89.78. So this car salesman, to be 99% certain of selling at least one car, has to see 90 customers in a day. Which is just bonkers, isn't it? You're literally going around shouting at people in town centres, do you want a car? 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 I think what we've learned throughout lesson 3 and lesson 4 is that this car salesman, we can assume it's the same car salesman because it's been the same probability of making a sale, really needs to find different means of employment.